Okay, quotient rule. First, let's recall the product rule for derivatives. Take the derivative of f times g. I'm going to abbreviate this and not write all the of x's out. I'm just going to say f prime times g plus g prime times f. And again, I don't really remember all the f's and g's and primes. I just know that it's the derivative of one times the other plus vice versa. Right? It's an equation by words. So people will end up writing this different ways. Like I could have written it as g f prime plus f g prime. That's the same thing. I could switch them the order. Since addition and multiplication are both, I forget the fancy word there, where the order doesn't matter. Commutative, associative, whatever. The order doesn't matter, so there's lots of different ways to write it. The quotient rule, though, in division, order matters, right? Like 9 divided by 3 is not the same thing as 3 divided by 9, so you got to get it right, and that's the same with quotient rule. So it's a little bit harder. So let's say we want to take the derivative of f of x over g of x. Okay, there's a little bit of parallel stuff going on here, in that the derivative of a product led to some addition. So what do you think the derivative of a division will lead to? Subtraction. Like I feel like that happens quite a few times in math. Exponents, derivatives. There's a few other things that we don't even talk about where, like this parallel where multiplication leads to addition, division leads to subtraction, and it happens again here. But with subtraction, the order matters. So here's how I'm going to write it. G of x times f prime of x. Again, it's one derivative and the non-derivative minus the other way around, but this time you've got to get it right on who comes first. So g f prime minus f g prime, and if only that was it, all over g of x squared. Okay, so without all the x's in there that kind of gum up the works, gf prime minus fg prime over g squared. So this one's a little trickier because you got to know which one comes first. So gf prime has to come first, and this is where the girls are going to do better at this than the boys, because especially in high school, females seem to understand better that for relationships and quotient rules to work, the GF has to come first. There you go. That's it. Ladies, you already know that, right? So this rule should come natural to you. It's the guys that maybe it takes us a little while, we're a little slower in these things to figure out. If you want life to go smoothly, you got to put the GF first. So GF prime minus FG prime over G squared. Happy wife, happy life kind of thing. Yeah, it's probably sexist. It may not be true, but if it's silly enough to help you remember it, then it's worth making the joke about. You may see some people write it as the derivative of top over bottom. So that would be what? Bottom times top prime minus top times bottom prime over bottom squared. So I've seen people write it like that, but then you can't use the GF joke. So GF prime minus FG prime over G squared. Again, so this was one that people get messed up because they get the order wrong. Like the structure is fine and is similar enough to the product rule that they know it's derivative of one times the other, but you've got to get the order correct. So super big deal. Now let's use it. So example, let's find the derivative of this thing. And again, we didn't say this on this one, but you wish you could just say, oh, let's just do the derivative of the top over the derivative of the bottom. Wouldn't that be nice? Like, well, yeah, it would be nice, but it doesn't work that way. So you've got to use the quotient rule to find the derivative of a quotient. So I'm going to write out the pieces again. So f is the top, g is the bottom. So the derivative of the top is 5, the derivative of the bottom is 2x. And then our overall derivative would be gf prime. So I got to get this correct. Gf prime. So 5 times x squared plus 1 minus the other way around, fg prime, 2x times 5x minus 2, all over the denominator squared. Well, we can clean that up a little bit. It is a safe stop, so you would be okay to leave that as a free response answer, but on a multiple choice test, we would clean it up. So let's see, that would be 5x squared plus 5 minus 10x squared plus 4x in the top. Yeah, distribute the minus sign. Look for like terms, so negative 5x squared plus 4x plus 5 all over x squared plus 1 squared. So, like a lot of the lessons in this unit, like it's not that hard, but it is something completely new. You got to know the rule. Number 2, find the instantaneous rate of change. Again, we keep using the different words to make sure you're familiar and comfortable with the different terms that all mean take a derivative. It'll be a little bit, save a little bit more space on this one. So the top is f, the bottom's g. F prime is 2x. G prime is, what's the derivative of cosine? Negative sign. Good. Okay, so the instantaneous rate of change, or dy dx. Gf prime. Gf has to come first to make it work. Gf prime would be this way, so that would be 2x cosine x minus the other way around, fg prime, x squared times negative sine x all over cosine squared of x. Let's see, is there anything we could do to simplify that? The minus stuff looks a little bit kind of weird, but that's about it for what we could do. And surely no one, there's a little note in the notes here like to not cancel cosines, right? You wouldn't do that. You know better than that. We'll pretend you know better than that. Number 3, slope of a tangent line. Again, that's a derivative. At x equals 3, so this is the one where follow the rule and then plug in pi over 3, so it's got that extra step at the end. So let's see, the derivative of secant is secant tangent. The derivative of x is just 1, so that'll make things at least kind of nice. Gf prime. Gotta go Gf prime. So x secant x tangent x minus secant of x all over denominator squared, all over g squared. just going to be kind of ugly with pi over 3's in there.
What's the derivative of secant x?
The derivative of secant x is secant x tangent x. Okay, our calculus part is over. Now it's unit circle and algebra. Pi over 3, secant pi over 3, tangent pi over 3, minus secant pi over 3, all over pi over 3 squared. We're going to have fractions and square roots and reciprocals. Okay, secant of pi over 3. I feel like we just did that. That was 2. Tangent of pi over 3 is the square root of 3. Secant of pi over 3, that's still 2. All over pi squared over 9. That is a safe stop. So on a free response portion of the test, you could stop there. So that's a perfectly okay free response answer. But on multiple choice, we would clean that up. And I think I would multiply by 9 over 9 to at least make the fractions go away, and then we'll see what anything else happens.
Say on an FR2 we were to continue and we did the rest of it wrong, would it still be wrong?
So you would lose some points. Yeah, you wouldn't get them all correct. So the question was, on a free response, you get here and then you mess up the algebra from there. Mm-hmm. Like, yes, you lose points. So you should stop there on a free response. It's more than just like you can stop there. It's like you should stop there. Just because, I mean, I don't think you're going to mess it up. You're going to get it right most of the time. But if everybody in this class does this problem, chances are pretty good that one or two of you is going to make some silly mistake along the way. Or phrase it differently, if you do 20 of these problems, are you going to go 20 for 20 in simplifying the algebra? Hope so, but maybe you go 19 of 20. And so if you have the choice, leave it. It's okay. It's encouraged. It's not, you're not chickening out. You're not taking the weak way out. No, you're taking the safe way out. Multiple choice, though, that's not going to be the answer choice. Let's see, the 9 and the 3 reduced to 3. 3 times 2 is 6. I've got 6 pi square root of 3 minus 18. And then over pi squared. That would be the multiple choice answer. And you know what? I shouldn't box one over the other. They're equally acceptable. They're equally correct. They are equivalent. And you ought to go with the first one if it's a free response question. And obviously if it's multiple choice, you're going to have to clean it up until it looks better. GF prime minus FG prime over G squared. Okay, this one looks a little bit different, maybe, but it's still a quotient rule problem. So let's identify F and G, and then figure out F prime and G prime. There goes some popsicle sticks here. Oh, we should totally do this. So, Naomi, you get the easy one, but sometimes people mess it up because it's so easy. What's the derivative of 7? 0. And Danny, how about the derivative of x cubed plus 8? 3x squared. Okay, so now it's just quotient rule time. GF prime minus FG prime. GF prime. Oh, well that's kind of nice. I guess I'll show my work here, but 0 times whatever is going to be 0. Minus the other way around. 7 times 3x squared over x cubed plus 8 squared. So negative 21 x squared over x cubed plus 8 squared And why are we not done with this problem? Because I got to plug in 2. It says find it at 2. So h prime at 2, negative 21 times 4 over, let's see, 2 cubed is 8. Really? We had to make it like this. 2 cubed is 8. 8 plus 8 is 16. And 16 squared is 256. If you didn't like that, I guess we could have just written out 16 squared as 4 times 4 times 4 times 4, and then canceled one of the 4s. Like, it's kind of a shortcut around this. And then 4 times 4 times 4 is 64. Or 4 over 256 is 64. So, either way, negative 21 over 64. Oh, and again, we could have stopped here for free response answer, but multiple choice would have been cleaned up to look like that. Okay, that's it for quotient rule. GF prime minus FG prime over G squared. Again, and students still, after a whole year of this in calculus, they'll still mess up the order. And on the AP test, like on this, you know there's going to be answer choices will be off by a sign because they know people are going to mess that up. So make sure you get this right, and that's why I do the silly thing about how the girls know it better, because you got to make the GF come first.
How do you know when you reach the safe stop?
Okay, that's a great question. How do you know when you reach a safe stop? A safe stop is when you are calculator ready, but not like scientific calculator ready, not graphing calculator ready, because graphing calculator ready includes integrals and derivatives. And so your calculator could actually, you could say this is calculator ready like way back here, because you could do math 8, I think it is. So we want the derivative of 7 over x cubed plus 8 at x equals 2. So you're like, yeah, it's calculator ready from the get-go, but you haven't done any calculus, so that you have to be careful saying calculator ready. Let's just check our answer here. Oh, it wouldn't change it for us, so we'll have to check it ourselves. There we go. So it has to be calculator ready, and you have to be, it can't have any calculus in it. Like, you gotta be done with the calculus. But this is just, usually it's just an algebra expression. Okay, higher order derivatives notation. So this isn't really anything new other than notation. So we're familiar with the first derivative, dy dx, we write that as f prime. If you want a second derivative, then just pay careful attention where the squareds are. The second derivative is the 2 goes on the d, and the 2 in the bottom goes on the x. You don't really have to memorize that, because if it asks for it, it'll be written there, or you could probably find it somewhere else on the test, or you could avoid it altogether and just write all your answers as f double prime or f triple prime. And then things would get a little out of hand if we said the fourth derivative was, 4 tally marks, and the fifth derivative was 5 little hash marks. And so we just switched to putting a 4, a 5, a 6, whatever number past 3. We stopped pushing the little apostrophes and just switch to a number. But this doesn't mean f to the fourth, it means the fourth derivative. All right. Number 5. Determine the second derivative. We haven't done this yet. Do you know how you find the second derivative? Right. You just take the derivative twice, so it's nothing new. Take a derivative twice. Okay, so my first derivative, this is going to require the product rule. I'm going to kind of do it in place in case I'm pressed for space here. So I'm going to do the first times the derivative of the second plus the second times the derivative of the first, which is 1. So there's my first derivative. My second derivative, now I'm going to have to do product rule on this piece and then not forget to do the derivative of sine. So, I don't know, maybe I should switch to showing my work here. Oops, so the second derivative now. Order doesn't matter with product rule. So I'm going to go negative x sine x plus cosine x. And then don't forget the derivative of this guy is cosine x. And I guess we should go ahead and clean that up a little bit. So negative x sine x plus 2 cosine x.
Is the derivative of cosine x negative sine x?
The derivative of cosine is negative sine.
Why is it not negative in the second derivative? It's negative x and then positive sine x for the second derivative. The first, should that be negative x negative sine x? Or just negative x sine x?
So I just put this negative out in front rather than write x times negative sine x. I just move that negative to the front of things. Which means I can kind of peek ahead here. Now every derivative after this is going to require the product rule, which is probably why they stopped at 2. As opposed to number 6, which asks for the fourth derivative. But it's a polynomial, so I could call popsicle sticks and get almost everybody on this one. Why don't you try this one? See if you can take it all the way down. First derivative, second derivative, third derivative, fourth derivative. But each time it gets a little easier because it's a polynomial. So, again, polynomials are nice because they get simpler as you go. Not polynomials usually get more complicated as you go. Number 7, second derivative at 1. It's a polynomial, so this won't be too bad. 4 minus 15x squared. Second derivative would be negative 30x. So at 1, negative 30 times 1 would just be negative 30. Alright, so that puts us up to worksheet 6, I think. Counting is right.